Alright guys, thanks for joining in. Let's quickly start with today's session. We got a bit late today, so probably extend it or try to do it faster, whatever works. Let's quickly resume with what you discussed in the last session and then we'll start with today's session. Pretty much we have covered strings, majority of the question related to string. There is one last question which is pending on the string apart from your assignment question, and then we'll continue with the stacks and queues. So agenda of today is going to be stacks and queues mostly. Quickly revising, we start with question number 3, which is lead code 387, first unique character in a string. It's a really good question. That's why I've tagged it as important. What did the question talked about? The question talked about there's a string given. There can be a repeating characters and non-repeating characters. You need to print the index of the first non-repeating characters. Now there can be multiple non-repeating characters. You need to print the index of the first one. For example, in this test case, the output will be 0. In this test case, the output will become 2. Now what's the solution? There are multiple ways. I can start with a brute force solution where I can run two nested loop. I can check for the first character which is non-repeated. I can return from there. Time complexity big of n square space big of 1. Or second is, since we are talking about frequency here, I can keep a map. In that map, my key will be character, my value will be frequency. The moment frequency becomes 1, I can return the character. Now in that code, if you're using a map, the order becomes important. Why? Because we need to return the first unique character. So in a hash map, my order is not maintained. In a linked hash map, my order will be maintained. In a tree map, my order will not be maintained. It will be stored in a sorted fashion. So if I'm implementing in Java, I'll probably use a linked hash map. Then we talked about third, which is frequency array. Again, frequency array is something similar, which is same as the hash map. Nothing changes in terms of time and space complexity. Now the order is important. I cannot create three different kind of array. Arrays of one kind, right? Map are of three types, but arrays of one type only. So I don't have a choice of creating a separate array. I will just create one array of size 26. But what I can do is I can compare with the string again to maintain the order. So I create a frequency array of 26. I equal to 0. I iterate over the string. First I increment the frequency and then I'm going over the string again to check what is the first unique character in a string, then return its index. Time complexity, I have to iterate the string twice, space complexity big of 26. Then we talked about question 4, which is lead code 3, longest substring without repeating character. These are list of three good questions which are in consecutive. Longest substring without repeating characters, and then longest substring without two repeating characters, and then k distinct characters. Okay, so let's solve all three of them in a template kind of a sequence. The question is, you're given the string s, you need to find the length of the longest substring without repeating characters. Now, here we're going to use a trick again that we refer to, which we call as translation. What is translation? When you say without repeating characters, means these are unique characters. And when you say longest substring, means I'm talking about maximum size of unique character window. So if my question become maximum size of unique character window, now my approach would be straightforward sliding window and set. Why? Because unique characters means set and maximum size of window means sliding window. So two possibilities will be there. If unique characters, basically which is not present in the set, I can increase the window size j++. If it is repeating characters, basically it is not present in the set, I can decrease the window size, I can do i++. And then I can maintain the answer, which is max of j minus i+1. So if I dry run like this, I put I equal to 0, j equal to 0, and so on and so forth. My unique characters, wherever I found, I'll increment the window size. Wherever I find that non-repeating character, non-unique character, basically repeating character, that's where I'll decrement the window size. Okay. And then I'll return my answer j minus i+1. So let's go to the code to understand that. This is length of longest substring. I'm given the string s. I start with I equal to 0, j equal to 0, max equal to 0. Here I create a hash set of character set. While my j is less than string dot length, if my set does not contain s dot character at j, means if it is not contained in my set, I need to increase my window size. I'll keep a max here. If not, I'm going to remove it from my set and I will do i++. I'll shrink the window size. And here I'm returning the max, which is just set dot size. Time comes to big of n, space comes to big of n. Then we move on to the variation, which is question number 5, lead code 159. The variation talked about longest substring with at most two distinct characters. Now, when you say at most two distinct characters, the previous question was at most zero distinct characters, right? So when you say longest substring without any repeating character, let me come back here. Longest substring without repeating characters, basically it is k unique characters. And in this case, I have two distinct characters. So if I put k equal to 0, it will become the previous question. Now, if I'm solving for two distinct characters, I can extend for k distinct characters also. So we're going to solve the third variation, which is longest substring with at most k distinct characters. And if I put k equal to 2, I'll solve the previous question as well. And this is the kind of template that we need to come up with. So in order to find that solution, when you say at most k unique characters, either I can use map or I can use a frequency array. My approach is going to be same, sliding window plus map or frequency array. I'm going to keep track of count of each character and my unique counter less than equal to k. If it is unique, I'll expand my window size, unique counter plus plus. If it is repeated, I'll decrease my window size, unique counter minus minus. I will maintain the window size using left and right pointer. So I come here while right is less than n, if frequency of s dot character at right plus plus becomes 0. I can increment my unique character count while my unique character count is greater than k. If frequency of s dot character at left plus becomes 0, means while I'm shrinking it, if frequency becomes 0, it means there is no repeating character. I can decrement my unique character count. And I can keep a count of right minus left. So I will know what's the k, what's that window size which will have the k unique characters. Time config of n, space config of 128. Same piece of code. We put k equal to 2 here and we have solved the variation for this one as well. Okay. All right. Then we move on to, this was a solution. I think there is one more solution. There's a simple solution which we have implemented in terms of this. Both solutions are same. These were the questions that we have discussed till the last class. Quickly give me clear if everybody clear with the revision. Any questions, any doubts, please feel free to ask. Come on guys, quick in the chat. All good. Today we have one question to complete with, which is valid palindrome, and after that we are going to start with stacks and games. This is homework anyway, so I'll remove this. Let's quickly get done with strings here. Question number 7. Lead code 124, sorry 125. Valid palindrome. Let's have a look at the question, then we'll talk about solving it. All right, this is a valid palindrome. Let's talk about the problem statement. So the question talks about a phrase is a palindrome. So this is a phrase, it's not going to be just a string. After converting all uppercase letters into lowercase letters, removing all alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. That's why it is called alphanumeric. Given a string S, return true if it is a palindrome or false if it is otherwise. Now given a string, let's say a man, a plan, a canal, Panama. So if you first convert everything to lower characters, so basically you make it case insensitive. You remove comma and everything which is not alphanumeric, basically alphanumeric means characters and the numbers, right? So if I remove all the non-alphanumeric characters and then I compare, so this will become exactly same. This is how it will look like if I remove everything which is non-alphanumeric. This is a palindrome. Since it is a palindrome, the output becomes true. If you talk about race a car, if I make it non-alphanumeric characters, if I remove them, it will become this. And you can see this is not a palindrome, right? This should be E and this is not E in this case. So output becomes false. Empty string is always a palindrome, so output becomes true. If you talk about s dot length, it's going for minimum 1 length and going up to 2 into 10 to the power 5. And if you talk about s consists of only printable ASCII characters. Okay. All right, guys. Pretty straightforward question. Just one implementation. The implementation is whenever there is non-alphanumeric character, all you have to do is you have to remove it. Okay. Any doubt in the question? Any doubt in the question? Valid palindrome. Alphanumeric character, non-alphanumeric character, just remove it from the string and then compare whether it's a palindrome or not. So if I take it here, I'm going to come back, go to Sublime Text. There you go. And there goes your problem statement. This is example explanation. All right, guys, the function that you have to complete, let me give you that as well real quick. This is the function that you have to complete. Boolean is palindrome, whether it's screaming whether it's a palindrome or not, true or false, and string s is given to you. Okay. Anyways, any doubt in the problem statement, anything which is not clear in the problem statement, let me know. Come on, guys, quick in the chat. If the problem is clear, just type clear in the chat. Everybody clear? Straightforward question, just some manipulation required. Okay. One question, does dot contain stack big of one time? Best and average case, yes. Worst case, big of n. Okay. Cool, guys. If everything is clear, you guys know the drill. This is your lead code problem statement. This is the function that you have to complete. Feel free to code in any language of your choice. Directly submit it on the lead code. Once you are done, share the submission link with me. Do not message to everyone. Share your message directly to me so you guys don't get disturbed and vice versa. Okay. Let me know once you're done. This is a pretty straightforward question. We should not be spending too much time on it. Once you get done, let me know. Then we can start the discussion. Your time starts now. Or there's enough time. Are we good to discuss? Are we good to discuss? Anyone needs more time? Let me know. Cool. Let's get this question quickly sorted, guys. This should not take this much of time. See, we already have done a question where we find out whether a string, well, can be a number or a string, is actually a palindrome or not. And how do we do that? We do that based upon, we talked about three approaches. We talked about the brute force solution by reversing the string. We also talked about the optimized solution, which was doing a two pointer. We keep one pointer at the beginning, we keep one pointer at the end, and we just keep on comparing the values. I hope everybody remembers that. A simple palindrome, we talked about two pointers, time comes to big of n by 2, space comes to big of 1. We can reuse the same approach. The only thing this time is, whenever there is a non-alphanumeric character, we need to just skip that. Whenever there is non-alphanumeric character, we just need to skip that. Okay, let's implement that via code, and then we can take it from there. I will show you the first C++ code, and then we'll move to Java code eventually, because C++ code is much easier to understand. Let's look at the code, what we are doing here. We are turning a boolean. We are taking a bool, as we call in C++. String s is given. We have two pointers, I and j. While I is less than j, what am I trying to do? So C++ default by default gives you a function called isAlnum. IsAlnum means whether it's alphanumeric. So if it is not alphanumeric, remember the note here. If it is not alphanumeric, I will just move on. I'll skip. So I'll move I++. If it is not alphanumeric, I'll do j minus minus. And then I'll compare if these are not the same character. So understand one by one. If it is not alphanumeric on the beginning, if it is not alphanumeric at the end. So line number 15 means what? It is alphanumeric at the both beginning and end. All agree? Look at the code sequence, then let me know. We are checking if it is not alphanumeric, do I++. If it is not alphanumeric, do j minus minus. So if my code is able to reach line number 15, means at index I and index j, 100% both of the values are alphanumeric. All agree? Any doubt? Any question? Come on, let's quick in the chat. Okay. So if both of them are alphanumeric, and if I convert them to lowercase, you can convert to uppercase also, totally up to you. If they are not matching, means they are not palindrome. Otherwise, if they are matching, I continue. I do I++ j minus minus, I'll continue with that. In the worst case, it will take complete iteration. So time complexity big of n, space complexity big of 1. Okay, I'm not taking any extra string. I compile this, looks good. If I submit, we'll pass all test case. Beats 100% because this is the most optimized way. Time complexity, as I said, big of n. Space complexity, as I said, big of 1. We can validate that. Okay. Now, if you're coding in Java, let's take this code first, and then I can talk about the Java one. Let's put it here. Very good. And complexity space complexity already listed. Okay. Now, the part that I was talking about in Java, the only trick with Java is alphanumeric is a method only in the case of C++. Yes, it's a standard method, so by default provided in the string.h class. Okay. Now, if you're coding in Java, there is no alphanumeric, right? So what you have to do is you have to use the method which is given by the character class. So character class provides you if it is a letter or digit. This is the by default function. Okay, so I'm not. You can see I'm not written a separate code. It is by default a function. Whether it's a letter or digit, and then I convert to lowercase. Exactly same piece of code, line by line, exactly same. Okay, just in Java. So if I take it here for Java folks, line by line, same code. Okay, here I'm applying two pointers. Here I'm getting the two characters. I'm comparing if it is not alphanumeric, start plus plus, not alphanumeric, last minus minus. Then you compare by converting into both lowercase, uppercase, totally your choice, then start plus plus and minus minus. Okay. Do you do it in JavaScript? I'm pretty sure there would be somebody who would have solved in JavaScript. I have not solved it, but I'm pretty sure there would be somebody who had solved it. So in JavaScript, there should be a default method for checking letter or digit. Let me check about it. Or if in meantime, if anybody has solved it, let me know. Can we do like that and check with includes function? Yeah, you have the regex expression anyways, right? We can do like that, check with includes function. I mean, includes what do you want to check? dot includes character or dot includes digit. Is that what you want to check? Instead of that, you can just do a regex match. That would have been much better. Okay. I have not coded in JavaScript, but I'm pretty sure there would be people who have coded it. I can write the code after this, but you can just do the regex one. I think regex would be a much better way. Somebody has pasted in the chat. You can paste it in a message to everyone so everybody can look into it. It's a fairly simple regex files. Yeah. All right. I reduced string to the desired form, then compared for palindrome. Um, you can do it, but I would not recommend doing that in the interview. The reason for that is if you modify the original string, then you would not be able to use the string for anything else, right? Think it like a production data. Before doing any kind of operation, good that you asked this question. Before you do any kind of operation, think, would you be able to reuse that data after? And if you modify that data, you will not be able to reuse it. One way of doing that is you will copy that string into something and then you will do it. Again, that creates extra space complexity of big of n. So question did not want you to convert it. Question just check whether if you remove it and then check it, will it be done or not? That doesn't mean that you have to actually remove it. Okay. So my piece of recommendation is until unless it's super important, don't lose the data because treat the data as a production data. Okay. All right, guys, let's move on to next topic. Pretty much we are done with our strings here. I'll mark this as done. Now we take the to do here, stacks and queues. Okay. All right. There we go. Let's talk about stack and queue. We'll cover into two parts. We'll talk about stacks. We'll talk about queues. And then we'll talk about the questions here. There's some really good important interview question which is asked on these topics, stacks and queues. We'll cover in the same pattern. We'll talk about the use cases. Then we'll talk about the applications. Then we'll talk about the code part. This is for stack. Exactly same thing. We are going to go in sequence for queues. Once we are done with that, we have a series of questions. We'll start with reversing an array or a string. Remember, guys, when we talk about reversal, the first thing I told you, stack would definitely be one of the solution. May not be the most optimized. Then the most popular question on stack, which is balanced parenthesis. Then we'll talk about variation of balanced parenthesis, which has been asked in Google. This question has been asked in many companies and multiple variations of it. Then next data element. Then we have daily temperatures and all those questions. Okay. Pretty good questions to cover on stacks and queues. Okay. Temperatures. I got a question, print all subsequence for a string. It's an important question. Not important per se, but depends on which company did ask this question and so on and so forth. Definitely not a question for online assessment. This can be something else for the interview. Okay. What was an online assessment? Okay, that's strange. For those questions, subsequence and everything, you can directly either run with the nested loop or you can run a recursive code as well. So both of the solutions are correct. These kind of questions we mostly discuss. One moment. These kind of questions we mostly discuss. As stored collection, we can write it down. These kind of questions that you talked about, printing all subsequence and all of that, we mostly discuss during backtracking because such kind of problems are related to that. Becomes much easier for like printing all subsets, printing all subsequences, so on and so forth. Okay. All right. I think a stored collection is in your assignment. Let me know if it is not there, else we can discuss it. Cool. All right, guys. Let's start with stacks. Then we'll compare with queues. But first, let's cover the stacks part. Cool. Starting with the data structure, what did I always mention about anything new data structure algorithm? You just need to know three things about the data structure algorithm to become a master in it. What is that? What, why, and how? What is the use case or the problem statement that DS or algo is trying to solve? What are its real life application and how it is coded or implemented? Now coming to one by one. What is the use case? What are we trying to solve, or what is the purpose of using stack? What stack as a data structure trying to solve a problem? To understand that, let's understand few terms. The only use case or the only purpose of a stack is to give the most recently used element in big of one time. It can get me the most recently used element in big of one time. When I say most recently used element, that means topmost element. It follows an order called LIFO, which means last in, first out, which is basically last element to be inserted is the first to be deleted. Okay. Now, before we go all these terms, we'll talk about cache and everything. Before we go through all these terms, let's try to understand this with a real life example, then everything will make sense. But to answer this again, the only use case of a stack is it gives me the most recently used element in big of one time. When I say most recently used element, it means the topmost element in a stack. Stack follows an order called LIFO, last element to be inserted, first element to be deleted. Okay. Now let's understand all of this with a real life example and then we'll revisit it. What's the real life example? Let's talk about it. If I take a simple packet of bread, okay, let me create packet of bread first. 5, 3, 2, and 1. Okay. Now what I'm going to do is I'm going to open this packet of bread. These are the 5 breads which are written here, and let's say there are 100 breads below 1 as well. If I open as a consumer, I'm talking as a consumer. If I open the packet of bread, what is the first bread I'm going to pick up? Come on, guys, quick in the chat. As a consumer, if I open the packet of bread, what is the first bread I'm going to pick up? The first bread I'm going to pick up is I'll open it, I'll take the topmost one. So I am going to pick the topmost bread. All agree? All agree? Okay. Now tell me one thing. How many operations or how many traversals in terms of number of bread I have to do to reach to bread number 1? I need to pick up 5, then I need to pick up 4, then I need to pick up 3, then I need to pick up 2, then I will be able to reach 1. All agree? That's the only way. I cannot directly just go and reach at the 1. I will take out all of those before 1. So I'll take out 5, I'll take out 4, I'll take out 3, I'll take out 2, then I'll go to 1. All agree with that? Okay. How many operations I need to do to pick up the bread 5? Correct. I don't have to do any operation to pick up the bread 5. Now here's the interesting catch. This bread, let's say it has currently 5. This packet of bread, let's say currently has 5 breads. And I'm picking the topmost bread. So to pick the topmost bread, I don't have to do any iteration. Agree? If I tell you these were 5 million breads and still I want to pick the topmost, will it make any difference in my number of operations? That's the beauty of stack. That's the whole purpose of stack. Okay. Now, this is what we understand from a consumer standpoint. Consumer standpoint, if I pick the topmost element, it takes me big of one time. Big of one time means irrespective whatever is the size of this packet of bread, which we are referring as a stack, it doesn't matter. As long as I'm picking the topmost element, my complexity is big of 1. All agree? If there are 10 breads, 100 breads, million breads below it, it makes no difference. Now, let's shift the classes and try to view this from the standpoint of a manufacturer. Whatever we see in terms of a consumer. Now let's think of a manufacturer. As a manufacturer, imagine that you are the one who owns the bakery and you are the one who is packing that bread. So imagine if these 5 breads that you have to pack, what is the first bread you will keep to pack the bread? What is the first element to be kept in the packet of bread? What is the last element to be kept on the packet of bread? Correct. See, if you're when you're packing it, when you're manufacturing it, you will put one on top of one, you'll put two on top of two, you'll put three on top of four on top of five. Why would you put that? Because there is something called gravity, right? That's why you'll put that. So you'll put one, two, three, four, five, and after five, you'll put the seal on it. So from a manufacturer standpoint, what was the last bread which was inserted? The last bread which was inserted was five. Now coming to a consumer standpoint, what is the first bread which is consumed? The first bread which is consumed is five as well. That is why I talk about the property called last in, first out. Last element to be inserted, first element to be deleted. Okay. So most recently used element. What was the most recently used element? It's the topmost element because this was the most recently inserted and this is the most recently deleted as well. Now we can document all this and then we'll talk about all of this. So my breads are placed one above another in a stack fashion. First bread is my top of packet. Five breads, one, two, five. Fifth bread on top. So you open the packet, access the fifth bread first, and to access the topmost element, which is my fifth bread. There is no iteration required here. Time complexity, big of one, which is nothing, which is constant time. What does that constant time means? That constant time means it is not dependent upon stack size. So even if my n is 100, or even if my n is 10 raised to the power 9, it makes no difference. Okay. Now read back the three lines which I talk about. Now this will make much more sense. Coming back to it, what is the use case of a stack? The use case of a stack is to get the most recently used element in big of one time. This is the most recently used element. We got this in big of one time. Most recently used element is the topmost element. We already discussed that. And stack follows a property called last element to be inserted, first element to be deleted. LIFO in short. Everybody crystal clear with the use case of stack. Come on guys, quick in the chat. Everybody crystal clear what kind of problem statement stack solves. Okay. If that is good, let's mark it as done. Let's move on to the second part, which is applications. Real life applications of stack. Why should we study stack? You have been using stack pretty much all your life without even knowing it. And why so? You will know it just now. What does this command do? What does this command do in keyboard? Come on guys, quick in the chat. I believe everybody has used Control Z, Control Y at some time. This is undo operation. What does this command do? Correct. This is redo operation. Is there anyone who does not know what is undo and redo? I hope everybody knows. Good. In case you don't know, just a simple real life example. Type anything. Let's say I'm typing Dave. I do Control Z, it's gone. I do Control Y, it's back. So redo is just reverse of undo, and undo is just reverse of the previous command that you have run. Okay. So type anything that you want in keyboard. Press Control Z and Control Y to see. Okay. Now, let's try to understand that. I believe the answer to this question everybody knows, but just wanted to ask it. What do you think is the data structure used or the algorithm used behind undo and redo operation? Okay, all of you know. You might have studied this in theory, and you might, I mean, in the theory, in the sense you would have been studying this from grade 11th, or that's the first time you have introduced about stack. Okay, so everybody knows this is stack, which is used in the undo and redo operation. A more interesting question is, do you need one stack for both undo redo operation, or do you need two stacks? Or let me ask this question another way. What is the minimum number of stack you need to do both undo and redo operations? Think and then let me know. What is the minimum number of stacks you need to do both undo and redo operations? Quick in the chat, guys. Based on data inserted. Okay. How does this matter? How does it matter if I'm inserting a string or an integer? All right, I'm getting conflicting answers. Some of you are saying one, some of you are saying two. Quick in the chat, guys. Okay, let's discuss now. Let's try to understand the working behind how does undo and redo happens, and then we can be in a better place to answer whether it's a two stack or one stack. Okay, let's say inserted 1, 2, 3, 4, 5. I inserted 5 elements there, 5 being the latest one. What would undo do? Undo will take the most recent operation and it will revert it. What will redo do? Redo will do the reverse of undo. Okay, so if I talk about stack here, 1, 2, 3, 4, 5. How will that be inserted? That will be inserted as 5, 4, 3, 2, 1. Okay, 5 will be on the top and so on and so forth. All agree? Come on, guys, quick in the chat. That's how my stack structure would be, right? Now tell me, what is the last operation that I did? When you inserted 1, 2, 3, 4, 5, what was the last operation that you did? Correct. The last operation you did was you inserted 5. So if at this moment I press Control plus Z, basically undo, what is going to happen now? What is going to happen? Correct. Fifth will be removed. So this would become 4, 3, 2, and 1. Basically, what would happen? This would pop. All agree with this? Now my 4 will be pointing at the top of the stack. Now if I do Control plus Y, which is redo, what will happen? What will be the structure of my stack now? Come on, guys, quick in the chat. Correct. Now my stack will become exactly how it was before. 5 will come on the top, then you will have 4, then you will have 3, then you will have 2, and finally you will have 1. I hope everybody is crystal clear with this basic understanding of undo and redo operations. Agree? Now let's go deeper into our question which we asked, one stack or two stack. See, when you do Control plus Z, on an overview level, what is happening? It is doing stack.pop operation. Okay. And I'm assuming 5, whatever that was pop, it is stored in some temporary space. Whatever that is, some temporary space it was stored. And when you do Control plus Y, it did stack.push that 5 again. All agree with this operation? Come on, guys, quick in the chat. Why do we need to store it in a temporary space? If I'm not storing that operation or number or value, whatever it is, I will never be able to do redo operation. Imagine if I do stack.pop and I permanently deleted that. Will I be able to do a redo operation? You will never be able to do a redo operation. The fact that I'm able to do redo operation is it's not a permanent deletion. Somewhere it is stored and temporarily it is stored. Okay. Now, answer to the question whether we need one stack or two stack, that's what I'm coming to. So how long it remains active? I don't think there is any time as such. It's based upon what's the last refresh that you've done, what's the last thread that is running. Okay. I don't think there's a timeout on the thread as such. So you can just to check it out, what you can do is do a control Z, close that window, open a new window, do a control Y. It will not work. But do a control Z, wait for maybe let's say 30 minutes, do a control Y, it will still work. Okay. So it's more about when the thread is in the memory rather than doing a timeout. It's not a HTTP connection anyway, right? Now coming back to the question that we asked, which is whether we need one stack or two stack. See, as long as I'm doing one operation means I do control Z and I do control Y. I am going to need only one stack. But does my programming or does my computer support or does my whatever term that you want to use, does my programming system supports multiple undo redo operations? Yes or no? So when I say multiple undo redo operation, I can write like this, I can write like this. I can do two control Z and I can do two control Y. So I do control Z, control Z, control Y, control Y. If I have to support multiple undo and redo operation, I cannot do it with one stack. In this case, I can use one stack, I can use one temporary variable. But what about these? These will be stored in a separate stack if I'm doing multiple operations. Okay. So the correct answer is I need two stacks, provided I'm doing multiple undo and redo operations, which is generally what you mean by when you ask undo and redo operations. Okay. The first application of using stack, undo and redo operation, in detail how it happens, minimum number of stack, all of those. Everybody clear? Give me clear in the chat. In one operation, why I need one stack? Because if it's one operation, I don't need to store in a stack just for one value. What I can do is I can create a temporary variable, let's say temp, integer temp, and I can store 5 there. That's it. I don't need a separate stack for it. But for multiple undo redo, I need a separate stack. Okay. All right. That was the first. Won't it be queued for redo because it needs first removed element? Depends how you want to see. Once you combine two stack, you can make it a queue. It's as simple as that how you want to do it. It's actually an implementation, implement queue using two stacks or implement stacks using two queues. So that doesn't matter. Okay. Clipboard also works in stack manner, I guess. Yes. Now, second operation. Your Netflix history or your YouTube history or your Chroming history or your browser history, whatever it is. Any sort of history for that matter. Let's say I'm opening 3 websites, GitHub, Medium, and LinkedIn. We open this at 6 a.m. I open this one as 6:15 a.m. and I open this one as 6:30 a.m. And if I check my history, what would I see in my history if I open these 3 pages at these 3 timestamps? Come on, guys, quick in the chat. Correct. The output would be LinkedIn, Medium, and GitHub. So those output would be in reverse chronological order. So you would have understood by now, you insert it in a stack, you got the reverse output in the stack format. This is simply a stack construction. Third, recursion stack. When we talked about recursion, we talked about recursion stack. What did we talk about recursion stack? It takes big of n space, it takes in auxiliary memory. And what else? It's used in the graphs algorithm as well. All the DFS based, they're implemented by a stack, technically by recursion stacks. All the BFS based, they are implemented by queues. Okay. These are your real life applications of using stack. Okay, let's quickly revise. First, undo and redo operation. Second, your history, any sort of history that you can imagine here. Third, your recursion stack. Recursion technically uses a stack, which we call as recursion stack. And fourth, in your graphs algorithm. LRU cache is about queue. LRU cache is not about stack. Okay. All right, guys. Everybody clear with the applications? Everybody crystal clear with the applications? Okay. So I'll move this part as done. And then I'll move on to next part, which is coding or implementation. So this guy is done. This guy is done. Let's move on to the code part of stacks. And then we'll start with keys. So to code, let's directly go on lead code. We can start coding from there and then we'll take it. All right, we are back on lead code. Let's start with this, convert into Java. Let's start coding on that. I'm just going to import java.hire.star, java.util.star. If you don't want to import star, you can directly import stack itself. All right, what we are going to do. First thing first, let's create a stack. The syntax is very simple. Stack, the data type that you want to create. So if I want to create, let's say for integer, I will say integer. Stack equal to new stack. Again, the data type, or you can keep it empty, whichever way works. First thing that I'm going to print is, I'm going to check whether my stack is empty or not. How do you check that? Stack dot, or let's name it as st dot is empty. What do you think would be the output here? I created a stack. Do you think it's empty? Do you think it's empty? If there's nothing in it, it will be empty. So output becomes true. This is empty. Okay. Let's push something to it then. Push means insert st.push, st.push, and st.push. If I start inserting it here, let's say I have inserted this, which element would be at the top? 3 will be at the top. Okay. So let's print it out. System.out.println. If I want to print a stack, and let's say I print st, what would be the output here? I will do st.peak. And what else? Let's also print the size here. st.size. Okay, one moment, guys. Let's answer for all three. st.peak is in Java, which is to check the topmost element. In C++, you have st.top. Okay. In Python also it's st.top. So what do you think would be the output for line number 16? Line number 16, output will be 3. Line number 17, size of the stack. Output again 3. Size of the stack is 3, guys. Output will be 3. All answers are correct except line number 15. Let me run the code and show you why. So line number 15, what it is printing is, it's printing stack as 1, 2, 3. But don't get confused. It's just printing in a linear fashion rather than printing in a vertical fashion. But 3 is still on the top. Whatever implementation, whatever thought process that you have in a vertical way, that is correct. See, in horizontal, in memory, it's not stored in vertical way, right? Memory is stored horizontally. That's why it is printing it horizontally. But however you have visualized it, 3 being on the top, then 2, then 1, although it is not stored in memory like that, but it's exactly behaving like that. That is why you see the top element is 3 and the size is 3 here. Everybody clear? Even though it is printing in a linear fashion, 3 is still the top element, and whenever you have print this side, the size is still 3. Okay. Now, interesting part. If I take this and if I talk about delete, if I want to delete something, I will do stack.pop. Which element do you think would be deleted? Which element is on the top? Top element is 3. 3 will be deleted. So you will have the output. Delete 3. So I clear it, run the code. Which element got deleted? 3 got deleted. And if I take it again, stack dot top, if I try to print the stack, now it will be 1 and 2. What will be the top of the stack now? Come on, guys, look in the chat. Stack dot pop is the operation for it. Correct. Now 2 will be on the top. And what else? Stack dot size will become 2 as well. This case, 3 will be on the top. And this case was 3. Let's run the code now one more time. And then we'll see. All right, what we got deleted? We got 3 as deleted. Stack will be 1 and 2. 2 being on the top, size becomes 2. Last thing, let's check for this guy as well. Where we started. Do you think your stack is empty now? Do you think your stack is empty now? It is not. So what do? You run the code. My stack is empty. No, my stack is not empty. So output become false. Everybody is still clear with this. Simple, easy code. How do you create a stack? You push the operations, you push the value, you pop it, you peek it, and that's it. Size is empty, those simple functions. Okay. Stack use a very simple piece of operation, guys. One moment. Let me paste it here. Let me paste the output here as well. There goes the output. All right, now let me answer your question. JavaScript doesn't provide any stack class, it provides array, which we can do both. Yes, we use array for them. I'm coming to that only exactly. All right, Java code, everybody clear? Simple creating a stack, how to create a stack, how to push value into it, how to pop from it, how to print the top element, and how to check is empty. These are the 4 functions. In C++, this is what you do. Stack whatever data type that you want, name of the stack. Let's say stack of integer s. We have insert function here. We don't have push there. We call s.insert1. Then s.pop is same. S.top is there. And then you have s.empty to check whether it is empty or not. For Python or JavaScript, we guys have the list or whatever you want to call as array. You implement same for stacks and cubes. Arrays, stacks, and cubes, all of them. Okay. All right, guys. Everybody clear? Come on, guys, quick in the chat. Cool. If this part is clear, let's move on to the next part, which is complexity of operations. More or less, there are 4 operations only that we need to do. DQ is double-ended queue. That's a different thing. So double-ended queue means you have insertion and deletion at both ends. If you talk about a normal queue, the insertion is at the last, which is rear, and the deletion is at the beginning. Double-ended queue is separate data structure. Is there any method remove in stack in Java? I'm pretty sure it would have been deprecated by now. Okay. Remove used to be, but I think it has been deprecated. You can double check. Pop is fine. Pop works completely fine, but the purpose of remove would be the same as well. Anyways, you can't remove from a particular index. You will remove it from the beginning on. Okay. All right, guys. Let's talk about complexity of operations. There are only 4 operations we are talking about. So let's go one by one, which is push, pop, is empty, and top. Peak basically. Always remember, where does the insertion happen and where does the deletion happen in a stack? Quickly in the chat. Where does the insertion happen? Where does the deletion happen in a stack? Correct. It happens at the top. Deletion happens at the top. Now let's talk about one by one all items. The purpose of push is to add an item. If I'm going to push something, what do you think is the time complexity? If I'm going to push something, what do you think is the time complexity? And why is that? Why is the time complexity big often? Go back to the packet of bread. In that packet of bread, if I have to put any bread above 6, do I need to make any changes? No, guys, it has nothing to do with memory. Stack has nothing to do with the memory here. Okay. The only point of contiguous memory is true in the case of arrays only. Only array is the data structure which works on contiguous memory. Apart from that, all the data structures are dynamic. Okay. So stack, queues, linked list, array list, vector, all of those data structure that you're going to talk about, they all are dynamic in nature. So don't mention about the continuous memory part. Coming to it. If you have to insert any element on top of the existing element, do you need to do any iterations? No, you don't need to do any iterations. You will just insert on top of it. That's where the complexity becomes big of fun. Okay. My time complexity becomes big of fun. However, however, whenever you're inserting something, there is something that you should always check for. What is that? Whether you have reached the capacity or not. If your stack is full, can you insert it? Let's say my packet of bread can contain 10 breads. If I try to insert 11 bread, what would happen? Correct. If your stack is full and then you want to insert it, that is when you will get the overflow. Overflow is a generic term. It's not just limited to stack. Overflow is with any data structure for that matter. Whenever the size has become to the limit, if you try to insert more, that is when you get the condition of overflow part. You would have seen this error stack overflow a lot of times. The reason of stack overflow is most of the time it comes in the case of recursion where you don't have a controlled recursion. In the case of a recursion, whenever recursion stack is full and you're still inserting elements on top of it, that is when it's a stack overflow. So when your size becomes equal to capacity, or a top becomes length minus 1, whatever you want to say, that is when you say stack overflow. Second operation, pop. Everybody clear with the first operation? Why the complexity is big of one, overflow case, everything? Come on, guys, put in the chat. Good question. Guys, have we discussed about array versus array list? One moment, I'll come to this. Have we discussed about array versus array list? Okay, like never discussed? That is strange. Okay, cool. If we never discussed, let's discuss it now. Let's talk about array. Let's talk about array list. Okay. Once discussed part of the question. Guys, it's confusing whether we discuss or we not discuss. Okay, if we not discuss, let's discuss it. No, I not just the array, I wanted to discuss something else. Array is a static data structure. Array list is a dynamic data structure. Everyone know that? Array is static in nature, array list is dynamic in nature. What does that mean? It's a different thing of knowing it, and the other part is understanding it. What does it mean to have a static and dynamic? Let's try to understand that part. If I create integer array equal to new integer 10, is anything wrong with this code? If I compile this code, if I run this code, will this code run? This code is completely correct. This will run. When you say static, what does that mean? Static means something which is not changing. Once you have defined it, it is fixed. You cannot change it. It's a fixed thing. That's why you call it static. What this line is telling to the compiler, what does array in general tell to the compiler? When array would come to the request to compiler, Compiler should know exactly how much space it needs to reserve. Okay. So when this code will hit the compiler will read it as I need to reserve 40 bytes of consecutive memory in my RAM. All agree? All agree? Okay. If I take this piece of code and I convert this to integer array equal to new integer, this. Is this correct code now? If I run this code, will it run? The answer is it will not run because there is no size predefined. This is incorrect. Okay. A classic real life example to understand this is think of like a movie ticket, right? Whenever you book any movie ticket, whenever you book any cinema hall or something and you want to see a movie ticket, the first and the foremost thing that you need to check is how many tickets you want to purchase, how many seats you want to occupy. Until the part you select how many seats you occupy, you cannot have the movie tickets. Exactly same thing. You reserve 10 tickets, you got the tickets. But if you say I want to watch a movie without telling how many seats do you need, you cannot have the tickets. All agree? Okay. There also you can categorize two more cases. Either you can pre-book it or you can buy it at the cinema itself. So if you pre-book it, this is the kind of pre-booking it. If you want to take it at the cinema itself, means you take it from the input variable and then you can decide it. So I can also do something like this, integer size, and I can input that size, whatever that size is. And then I can say integer array equal to new integer size. This is also fine. As long as before we hit this line, you have that value exact, it is completely okay. Okay. All right. Quick in the chat. Array list, linked list, they pretty much all the list interfaces, they work in the same way. So no need to worry about, we're covering all of them now. Linked list will cover separately, but everything which is extended from the list and collection framework, they work in the same way. Now coming back to it, guys. This part of static being in nature clear to everyone? Okay. Now let's talk about array list or in general anything which has come from the list collection framework. When we say array list is dynamic, what does that mean? Let's look at this code. Array list of integer array list equal to new array list of what? Integer. I can just insert one moment, 2, 3. Now, heap is only for the runtime memory. This is not runtime memory. This is static memory. Okay. And if I do system.out.println, I print al.size. What do you think would be the output now? Come on, guys, quick in the chat. The output will be 3 here, which is 3 elements in my array list. Now, the interesting line here is line number 463. When I created this array list, did I define any size? When I created this stack, did I define any size? The initial size was 0, of course, that's why it was empty. When I inserted, size became 3. When I deleted, size became 2. But I did not define any size. I did not define any custom size. I did not define any final size and so on and so forth. Okay. Similarly, in the case of array list here, I did not define any size. I inserted elements, it will keep on increasing. I decrease elements or I deleted element will keep on removing. But I did not define what is the size, what is the capacity, and so on and so forth. So what happens behind the scenes? When we say about dynamic in nature, what is exactly happening according to you guys? How it is that I'm not defining any size, but based upon however values I'm inserting, it is able to increase its size. What is that magic happening behind the scenes? Come on, guys, think about it. You don't need to give an accurate answer, but you would know that there would be some kind of processing happening behind it. When you don't define a size and you keep on inserting the element, it is incrementing it. And then when you're reducing it, it's decrementing it. So there should be something which is happening behind the scene, which is helping it to scale the size and reduce the size. Agree? All agree with this part? There is something happening which is asking it to scale the size based upon the number of inputs and decrease the size. What is that something which would have happening? Correct. See, there is no magic. At the end of the day, array list is also being implemented on top of the array, right? There is a default size. I'm not denying that. But once you reach that default size, it automatically increases itself. How does it increases? Let's talk about it. The default size is 256. And when you reach to the default size, what is going to happen? It's going to auto expand itself to 1.5x of previous size. This is after JDK 1.8. Earlier, the new size used to be 2x of previous size. Okay. I'm going to share something. If you want to read more about it, let me share this. I thought I've already covered this in your class. That's why I did not cover it. But anyways, let's get it here. There's a very good article from Tutor's Point. Just refer to it. This explained everything that I said. I'll walk you through that article as well and read about it once you get time. Let's see. Okay, I don't see it here. Nope. Okay, I think they might have removed that article or something. Okay, fine. I mean, that article is not there anymore. But anyways, Geek for Geeks has an article as well. Let's check the Geeks for Geeks one. The website was Java Point that I was trying to find, but didn't find it anyways. Okay, nevertheless. This is the same thing which we have just described over here. How does the array list get started? What's the default size? How it adjusts for 1.5x and 1.2x? All of those things. Okay. This is something that you can refer here. This is the 1.5x part I was talking about. This code. Okay. There you go. And there you can read about it. I'll take this. You can get back here. Okay. Sharing in the chat here as well. And that is how all the dynamic data structure works, not just array list itself. Anything which is dynamic, that's exactly how they work. They have default size, and once you increase that, once you get closer to it, can continue with that. And once you close it, and that is when it will change the size for it. Okay. Now coming to the part, somebody asked, what is the default stack size? If you create just a normal stack, by default it will be 256, but it will keep on increasing. However, however, you can create your custom stack as well. In that custom stack, you can define what is the size you want to keep there. Okay. All right, guys. If everybody clear with this, shall we move to next operation? Push operation and this question, everybody clear? Let's move on to next operation, which is pop. The purpose of pop is to delete the item. So if I'm deleting the item, what do you think is the complexity? Come on, guys, put in the chat. Go back to the packet of bread whenever you're confused with any question in style. Packet of bread, I have to take the topmost element. What is the complexity? Correct. To take the topmost element, the complexity is big of 1. In which case you cannot delete it. If my stack becomes empty, then I cannot delete. That becomes underflow. Okay, time constantly is big of 1. What about the code part? If not stack dot is empty, that is when you do stack dot pop. Always check whether my stack is not empty. Okay. When the stack is not empty, only in that case you will do the pop operation. Just to be clear. Third part, peak slash top. This get you the top element. What's the complexity to get the top element? What is the complexity to get top element? We already know it. It's big of 1. Last operation, and this is an interesting one, which is stack dot is empty. Basically, it returns true or false. If you have to check whether the stack is empty or not, I need 2 things from you guys. First, let me take this. First, what is the, if you need to delete mid element 2, then stick time must be bigger. No. The deletion complexity is only big of 1 for the topmost element. If you're going to the mid, you have to go to all the elements till then, and then you have to delete. So if it is in, let's say, position k, you have to do big of k operation. K minus 1, big of k, same thing. Okay. All right, now coming to it, the last operation, which is empty, I need 2 things. First, tell me what do you think is the complexity to check whether a stack is empty or not. And second, sometimes it is asked in the interview if you have to implement is empty function. You don't have to use the default is empty. You have to implement is empty function. How would you implement that? Let me know the answer for 2. My question is clear. I'm asking 2 things. First thing, what do you think is the complexity to check whether a stack is empty or not, along with the reasoning? And second, if you have to implement this function to check whether a stack is empty or not, how would you implement it? What is the code that you will use? Okay, think about it. Let me know, and then we can discuss. I can give you 30 seconds for this one. Once you guys are done, let me know, then we can discuss. You can message to everyone, completely fine. Quick in the chat, guys. All guys, enough time. Shall we discuss? Cool. I've seen a couple of answers, couple of very different answers in the chat. Let's see. Some people are saying we need to check the length, and length works in big of 1. Fine, no issues with that. Do I need to check? Okay, let's understand the root cause. What I'm trying to do is I need to check whether my stack is empty or not. For that, do I really need to calculate the length? Do I really need to calculate the length to check whether it is empty or not? The answer is no. Basically, just to give a context, what I'm saying is, there you go. Where's a packet of bread? If my packet of bread has 100 bread, do I need to check if it has 100 breads? The question is whether it is empty or not. The question is not how many breads it has. If the question is about how many breads, yes, let's count. 100 breads are there. But if the question is just it's empty or not, I don't care whether they're 100 bread, 200 bread, 500 bread. What I do care is on the top if there is any bread. Even if there is a single bread on the top, it is not empty. Otherwise, it is empty. I don't care about what is the size in the breads. All agree? Only on the top, if something exists, means it is not empty. If it does not exist, means it is empty. So only thing that I would need to do here is, if I have to implement this, stack.peak is equal to null. Or basically stack.peak basically. That's it. So time complexity of this is big of 1, and that's it. So all 4 operation, push, pop, peak is empty are big of 1 operations. Everybody clear with this? Come on guys, quick in the chat. Okay. If everybody's clear, now let's talk about your application-based question, and then we can start with the queues. Then we'll start taking date code questions. Internet stores element array like it, store like this. Yes, everything which is dynamic works the same way. Now, coming to the application questions. What is happening in application questions? I know if I put 1, 2, 3 in a stack, my output will become 3, 2, 1. What does that mean? And I'm going to write a very important statement. Order of values in stack slash output is reverse of order of insertion. This is a very important statement. Order of values in stack is reverse of order of insertion. Means what? Anytime I need a reverse order kind of a thing, my stack would definitely be one of the solution. All agree? Come on guys, quick in the chat. Okay. For that, let's take a quick question. Reverse a string or an array. What are different approaches we talked about? We talked about I can use inbuilt reverse function. If I do that, what would happen? Time complexity big of n, space complexity big of n. Second, I can create an extra array and I can traverse from right to left. In that case, time complexity big of n, space complexity big of n. What else? Two pointers and swap. Time complexity big of n by 2, space complexity big of 1. What else? Travel till half and swap. Again big of n by 2, space big of 1. And finally, if I'm using stacks, time comes to big of n, space big of n as well. Stack uses extra space of big of n. Take ABC, put it in a stack, output will be CBA. All right, that's it pretty much in the theory of stack, guys. Before I start with queues, I'll quickly revise what we discussed as part of the stack, and then we'll start with the queues part. Okay. All right, coming to the stack, we start with three things. What is the use case? What is the CLF application? How it is coded and implemented? The use case is it takes the most recently used element and big of one time. When you say most recently used element, that means the topmost element in a stack. It follows in our order called LIFO, which is last in, first out. Real life example we talked about, which is packet of bread. So let's say if I take a packet of bread, the last element inserted will also be the first element to be deleted. Breads are placed one above another in a stack order. That's what we talked about here. Works in a constant time, so irrespective whatever the size of the stack, it doesn't matter. Then we talked about applications, undo and redo operations. How does undo redo operation looks like? What's the minimum number of stack we need? All of those we discussed. Any kind of history that you can see, streaming history, Netflix history, YouTube history, all of that stack would be used. Recursion based questions, recursion always get a recursion stack, which is big of an auxiliary space. That's where stack is used. Graphs algorithm, DFS are built on stacks, BFS are built on queues. And then we finally write down the code. We understand, talk about push, pop, peek, and is empty functions. Then we talked about difference between array and array list in general versus static versus dynamic data type in general. Then we talked about complexity of operations, push, pop, insert, push, pop, peek, as well as is empty. All of them are big of one operation. Only thing to consider while you're inserting, just take care of the overflow. While you're deleting, take care of the underflow part. Then finally moving to the application question, wherever the order you need in a reverse value, that's where stack would be one of the solutions. Everybody crystal clear with the stacks. Come on guys, quick in the chat. Everybody crystal clear with the stacks. All good? Now we are going to do the same thing for the queue. We'll go really quick. I want to cover the theory today so we can focus completely on the questions tomorrow. Okay. Whatever we did for stack, we're going to do sequentially for queue as well. We'll talk about what is the use case problem queue is trying to solve, what is the life application, how it is called or implemented. Okay. Just like stack has a property, queue has a property as well. Stack gives me the most recently used element in big of one time. Queue gives me the least recently used element in big of one time. Okay. When we say least recently used element, what do we mean? Least recently used element is nothing. It is the front element in queue. It follows an order called FIF order. What does FIF order means? First element to be inserted is the first element to be deleted. Okay. Also called, okay, let me write it here. First inserted is the first to be deleted. And it is also called FCFS, which is first come, first serve. That's it. Okay. We'll try to understand all of this with the real life example as well. But before we go there, let's quickly revise. The use case of a give is to give you least recently used element in big of one time. How do we define the term least recently used element? It's the front element in the queue. It follows an order called FIFO, means the first element to be inserted is the first element to be deleted, which is also called FCFS, first come, first serve. Everybody clear so far? Everybody clear so far? Okay. Implement stack and queue in the interview might be not very carefully. I would say maybe 1% chances there you might be asked to implement, write a custom stack or write a custom queue. There are questions on LeetCode for that as well. Okay. Yes. Yes. It grows like array list. See, don't differentiate between array list or stack in general. Understand dynamic data structures versus the static data structure. Dynamic data structures scale like that, right? Because they are not referenced, they are not limited by contiguous memory constraint. Static data structure is limited by contiguous constraint, which is the array part. Okay. Why people are using array instead of array list? Array list is a dynamic memory. See, array has its own purpose, array list has its own purpose. The purpose of array list, one moment. The purpose of array list is just to have the dynamic memory allocated, right? The purpose of array is wherever we want the static things to be continued. Static things in the sense wherever we want the contiguous memory. So I can decide the contiguous memory. I will be able to calculate the memory size. All of those cases, array is where it is used. Okay. Just because we got array list doesn't mean that we have deprecated arrays in general. The purpose of array is to make sure that you're using the contiguous memory and utilizing the full part of it. Okay. If stack is dynamic data structure, how is the max size decided? That's what I said. By default, the size is 256. Anything on the list interface, the size is 256. And on top of that, you keep on creating it. Okay. That's what I said. It's 1% chance they can ask about to create a custom stack or a custom queue. It's a 1% chance. And there are lead code questions on creating a custom stack and custom queue as well. Okay. When will we hit overflow? Yes, at one point, definitely you'll hit overflow, right? See, once you have no memory in the RAM exactly, what exactly dynamic is doing? Dynamic is only thing focusing on is wherever it finds the memory, it creates a node there. That's how linked list works. That's how any dynamic data structure works, right? But in one moment, even if you're, let's say you're using a RAM of 8 GB or 16 GB, whatever it is, if you create an extremely large size, at one moment it will die out. Okay. So there is going to be a threshold for sure, depending upon your RAM and whatever the space is available. Right. All right, guys. This was for the queue. Let's talk about the real life example to understand that. The real life example for a queue is pretty much a queue. So you can think of any scenario where you find a lot of queue. So let's take this. This is front. I'm going to print a bank counter. Okay, let's not name any bank. You can imagine any bank which has a lot of queue, which I believe pretty much all the banks have. Anyways, there are two kind of operations we are going to talk about. Insertion and deletion. Okay, let's understand the use case first, then we'll talk about these operations. So On the right side, you can see there's a bank counter. So there would be a bank employee here who will be helping with these customers. On the left side, there's a queue of customers. The F is the first person who arrived. Then there would be a second, third, fourth, fifth, so on and so forth. And R is the last person, which is rear, we are calling it. Now, obviously, the reason that they have made queue is because first F is the person who came first. Then this guy, this guy, this guy, this guy. R is the person who came last. Everybody clear with this? Everybody clear with this? Okay. Now let's say there's a new person who wants to enter in the queue. Where exactly that new person would be placed? Correct. The new person would be entering at the end. That is what we call as insertion operation. Insertion happen at the rear. This operation is called in queue. In queue operation. Okay. Now let's talk about the deletion case. Let's say F came to get his passbook updated or whatever task it was doing. Now the task is done. Once the task of F is done, what would be the first element to be deleted? Of course, F would be the first element to be deleted. Can this element be deleted before F? Can R be deleted before F? Can new be deleted before F? No. The whole purpose of them, they are following in a queue fashion. When I say by queue fashion, this is what I mean. They are following in this fashion only. This guy came for whatever task it came to. Once it will get done, then it will be deleted. Then this guy will come, then it will be deleted. Then this guy come, then it will be deleted, and so on, so on, so forth. Okay. Till the part everybody is not done, new will not be deleted. Okay. So my deletion happens from where? My deletion happens from front. This operation we call as DQ. Okay. Here also I want to clarify something which is not immediately required but would be good to know. DQ or DQE, if you want to read like this, versus DQ. Although they sound same, these are two different things. When we say DQ, that means it's an operation. You have deletion from the front. When you say DQ, that means double-ended queue. Let's say data structure. Okay, where you can insert at both and delete at both ends. So these two are separate terms. Just notice the word. If you put D in front of the Q, means you're referring to an operation. If you're talking about DQ in general, that's a data structure. Okay. So coming back to our Q part, we got F to R. They follow first come, first serve, which is FCFS. F would come, will get the job done. Then second will come, third, fourth, fifth, and then R will come. They follow in the same sequence. They are inserted in the same sequence. They'll be deleted in the same sequence as well. Everybody crystal clear with this? Come on, guys, quick in the chat. Everybody crystal clear? All good? Cool. Then real life application is good. Now let's move into the complexity of operations. Remember, in a queue, before you go to the complexity, where does the insertion happen and where does the deletion happens? DQ is just a deletion, that's it. In queue is what we call as insertion. DQ is what we call as deletion. That's it. It happens from the front, insertion happens from the rear. But guys, coming back to it, where does the insertion happen? Where does the deletion happen in a queue? Quickly in the chat. In a queue, insertion happens at the end, which is rear. Deletion happens at the front. Okay. Now, let's talk about these operation one by one. In queue is insertion happening at the rear. TQ is deletion happen at the front. What do you think would be the complexity of both of these operations? Quickly in the chat. Anything that you need to take care before you insert or before you delete? Think about it, guys. Anything that you need to take care. See, if a queue, let's say, has a size of 10 and there are 10 people already, can you fit the 11th person there? No, you cannot. So in the case of insertion, and not specifically to stack and queue, in general, any data structure, if it is full, you cannot insert it. That will be overflow. Okay. Time complexity to insert is big of 1. Why it is big of 1? Because inserting at the end. So if I'm inserting something at the end, I'm not going through any iteration. Agree? If a nuke has to come at the end after the R, it does not have to go through anything. So the complexity becomes big of 1. Now coming to the DQ operation, means deletion. Deletion happens at the front. Deletion happens at the front, the complexity is still big of 1. Why? Because when the F would be removed from here, F does not need to iterate through anything. F will be deleted, F will go home. That's it. Now when you say at front, I need to check whether my queue is empty or not. If my queue is empty, that condition is called underflow. Okay. All right, guys. And if I check in the code, this is what you'll be doing. If not, queue dot is empty. That is when you're going to do queue dot remove. Remove is a function here. Okay. All right. Second part clear to all. In queue and DQ, insertion and deletion basically. As I said, by default, if you're using by default queue size, you will not be able to know when it is full. If you're creating a custom queue, you will define the capacity of the queue. Okay. All right. Coming to third part. Front. Front gets you the front element. So what do you think is the composite to get the front element in the queue? If I have to access F, how many operations I need to do? I don't need to do anything. If it's already in the front, I don't need to iterate anything. Complexity becomes what? Big of 1. Fourth, to check whether my queue is empty or not. Again, it gives you true or false. Basically, the queue is empty or not. What do you think is the complexity required? And I want you to write this function boolean is empty as well, just to check whether a queue is empty or not. Okay. Same two questions as we have in the case of stack. Two things. What is complex to check whether a queue is empty or not? And second, how would you implement this function boolean is empty if you're asked? Same 30-second, guys. Quick in the chat. Let me know. Come on, guys. Quick in the chat. If I need to check whether my queue is empty or not, do I need to calculate the size of the queue? No. Think it from a bank counter perspective. If you need to check whether a queue is empty or not, only thing that you need to do is you just need to check whether there is any element in front of the queue. Doesn't matter the queue size, even if there is one person, the queue is not empty. So only thing that I need to check is if my queue.front is null or not. That's all. Time complexity, big of 1, and that's it. So all for operation in queue, DQ, front, and is empty is big of 1 operation in a queue. Everybody clear with this? DQ is deletion, right? See, if you have to delete something, the last element which will be deleted, the first element which got inserted will be the element to be deleted. So if you have to delete something, deletion takes big of 1 time. For example, the F is deleted from the queue. When the F is deleted from the queue, F doesn't need to iterate anything. F is deleted, F goes home. That's it. Okay. All right, guys, that was comparative operation. Let's move on to the applications and then we'll continue with the code part. Let's talk about applications real quick. First thing first, since it has the property of least recently used, it's highly implemented in the LRU cache. Okay. So front 1, 2, 3, 4, 5, 6, 7, 8, let's say, to rear, it's implementing the property of LRU cache. Second, it has a lot of use case in operating system in terms of CPU scheduling. Now let's talk about this problem. What do you mean by CPU scheduling? So CPU has different threads and processes for tasks, which they implement in a queue format. We'll talk about why queue specifically. FCFS, FIFO. Let's talk about this. If I log into PC, let's say there are 4 operations. If a user click on Chrome, then user click on VLC, then user click on, let's say, Spotify, and then user click on, let's say, VS Code. What do you think in which order the user wants these applications to open? Obviously, at the end of the day, whenever you click something, there will be a process and thread associated with that. And that process and thread will be actually in your CPU, that's which has a RAM associated. And that's how that operation will be popped up. My question is, there's a customer or a user, let's say in a PC, and the user clicked Chrome first, then VLC, then Spotify, then VS Code. In which order user wants these applications to open? Come on, guys, quick in the chat. If you are a user, you click like this, in which order you want them to open. Obviously, you want them to open in the order that you have clicked. Is it mandatory that they will open in the same order? Has it ever happened that you clicked on second application, but that got opened before the first application? It might have happened, right? But the root cause for that is different. I don't want you to confuse that too. But ideally speaking, if a customer clicked in this sequence, the customer wants to open this sequence. So let me ask a question, why queues and not stacks here? See, if I'm storing this in the queue, it'll follow the same operation. Chrome will open, then VLC will open, then Spotify will open, then VS Code will open. But if I put it in a stack order, reverse will happen. VS Code will open, then Spotify will open, then VLC will open, then Chrome will open. Okay. And that is definitely not what we want. A customer wants this, we'll give this form. That's why queue is used here. There is first part. Okay. Second part, the question that I asked, does it always open? The answer is no. And that is not related with queue or something. That is because of the system resources. Let's say it's a very read intensive application. If it's a read intensive application, let's say this is a very small application. So whichever is readily available by the to be picked by the CPU, that will be opened first. Okay. Nothing to do with queue or stack here. It's as simple as whichever is available, it picks it up. Whichever is fast in execution. Okay. All right, guys. CPU scheduling clear to all? Every asynchronous things that you are doing, they are based upon queue. Even a simple SQS, which is simple queue service, they are implemented by queues only. Okay. DL queues are queues as well. All right, let's move on to the third application. Input output buffers. What are IO buffers? Let's talk about it. Any sort of buffer and time for submission, they are stored in a queue order. Time is used to determine the rank. One moment. Less time means less. Okay. Now think of a use case where you are designing a system for a leaderboard, either a real-time leaderboard or you can think like top key leaderboard for something. It can be a game design leaderboard, can be just let's say a problem contest leaderboard. It can be quiz leaderboard, lead code leaderboard, any kind of a game design leaderboard. Now what you would need is you would definitely need a timestamp based upon that at what timestamp what particular ID has made a submission stored in a queue along with some form of metadata about the customer, right? And based upon timestamp, your rank is going to be generated. So first submission would be rank 1, second submission would be rank 2, and so on and so forth. Whichever is submitted first will get the rank 1. That is how you will implement a leaderboard, the game leaderboard or contest leaderboard, whatever it was. Just if you have to think in terms of a system design. All agree, Q would be the data structure to be used here. All agree. Okay. However, if we have implemented via stack, what would have happened in that case? If implemented via stack, in that case, whoever is submitted last would get the rank 1. And that's something which we don't want. Okay. All right, guys, that's the real life applications of Q. Number 1, LRU cache. Number 2, CPU scheduling. Number 3, input output buffers. Basically, any game design leaderboard. Okay. To your question, we are closing the third application without closing the first one because these are independent threads, so you can close them. Okay, but they consumed in the order of Q. Cool. 779. Shouldn't less time be more rank? Less time be more rank? The less time that you will take to submit something would be the less rank that you will get. Less rank means decreasing rank. Rank 1, rank 2, like this. That's what you mean by less rank. Okay. All right, guys. If this part is clear, we can move to the code part of Q. Let me know. Everybody clear with the application? Then we can start with the code part. All good? Cool. Let's go to the code part. We're going to leverage the same platform. Let's go back to read code. Let's start coding here. Okay. Cool. I'm going to clear this. We are going to modify this code to make it a queue. It's pretty much similar to what you have in the stack. You would have queue. The only thing is the queue is not implemented by a queue interface. It's implemented by a linked list interface. Okay. There's no queue interface in Java, by the way. So list is extended by stacks, array list, and vectors, but there's no queue interface. So we implemented by a linked list interface. First thing, I'm going to check whether my queue is empty or not. So I'm going to name this as queue. Let's check whether my queue is empty or not. I'm going to delete everything else. What do you think would be the output? It is empty. Yes, it is empty. There's nothing there. What I'm going to do? I'm going to insert. Now, we had push operation in terms of a stack. Now we'll have add operation. Q dot add 1, Q dot add 2, Q dot add 3. So this is insert at the front, and this is the rear. Now what we want to do? Yeah, in queue operation, insertion operation, same thing. Now we want to check what is our queue. So what do we want to print? We want to print the queue. Then we want to check which is the front element. We want to check what is the size of the queue. So queue dot element is in the code in Java. Queue dot front used to be there. Now it is not there anymore. Queue dot size will do it. All right. Now, what do you think would be the output of these three lines, 14, 16, and 17? Come on, guys, quick in the chat. Because there is no queue interface in Java. Queue uses the linked list interface to implement that. Okay, cool. This part here, it is 1, 2, and 3. 3 being the rear element, F being the front element. If I print the front, what is the front element? 1 is the front element. And if I print the size of the queue, that is 3. So if you run the code, you will get true. Queue is 1, 2, 3, front is 1, and the size is 3 here. Everyone crystal clear? What next? I want to delete something. So I would have something deleted. How do you delete? You do q dot remove. Which element will be deleted? Deletion happens from the front, 1 will be deleted. Now if I print the queue, it will contain only 2 and 3. Front will become 2, side will become 2. All agree? Come on guys, quick in the chat. Let's print it. This is fine till last part. Deleted is 1, queue becomes 2 and 3, front becomes 2, side becomes 2. Last part, where do we start it? Is my queue empty now? No, my queue is not empty. Pretty much simple code, just like we have the stack. This is for the queue part. Let me take this, come back here. There goes your code, and there would be your output. All right. Everybody crystal clear with the queue part. Code of queue part. I will revise it again, but the code of queue part at least. Okay. Let me give you the alternative in C++ and Python and Node, guys. See, in C++, it's queue, whatever data type that you want to give, and name of the queue. Example, queue of integer, name it as queue. Q dot insert is the function there. One Q dot front is in C++, and Q dot erase. Okay. In Python or JavaScript, guys, there's a list which works with arrays, stacks, queues, array list. Okay. All of them. That's pretty much all the theory in terms of stack and queues. Let me quickly revise the queue part of it. Stack part we have already revised, and then we can move on to the question part of it. So first thing first, same in terms as we discussed in terms of stacks, we discussed in terms of queue as well. If you want to become master, now three things about. First, number one, what is the use case or problem? Number two, what is application? Number three, how it is code or implemented. The use case of queue is to get the least recently used element in big of one time. Least recently used element is also the front element in the queue, which follows an order called FIFO, first in, first out, or FCFS, first come, first serve. A real life example, this is my queue. Let's say this is my bank counter. This is the first person. This is the last person. Insertion happens at the rear, deletion happens at the front. Okay. Now, insertion operation is called in queue, deletion operation is called dequeue. We talked about the complexity of operation. Since my insertion happens at rear, deletion happens at the front. Complexity of insertion is big of 1, complexity of deletion is big of 1. To check the first element or the front element is big of 1. Whether to check whether a queue is empty or not, that is also big of 1 operation. In terms of the applications, where it is queue is actually used, it's used in the LRU cache, it's used in the CPU scheduling, as well as input out buffer for designing a leaderboard. Then we talked about the code part. In terms of code, we understood how do we implement a queue, how do we insert, delete, get the first element or get the front element and check the size whether the queue is empty or not. All right, guys, that's all in terms of theories of stacks and queues. Let me know if everybody is crystal clear, then we can start with our questions. Everybody crystal clear with stacks and queues theory? Okay, all good. Let's start with our first question on lead code. Even though we don't get time to solve, we'll continue over tomorrow's session. Tomorrow we'll be completely focusing on the stacks and queues questions to solve. Let's start with question 2. Question 1, I'm referring to the reverse string. That's why I'm not writing as question 1 here. Question 2 is very, very important. Let's name it as valid parenthesis. You would have seen this question multiple times. I'm pretty sure all of you would have solved this question. But if not, let's understand what this question is about. All right, guys. The explanation will take some time. So let's go step by step and make sure that we are clear with this. This is lead code 20. The name of the question is valid parenthesis, and you can look at the summation 14.2 million submission. It's a huge, 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 huge number of submission. And surprising part is after that, even after that huge number of submission, less than 50% got accepted. Okay. If you look at the likes, 25.7 thousand likes. If you look at the companies, a lot of good product-based companies have asked this question very recently. Okay. Now let's talk about it. The question is you're given a string S containing just the characters, opening bracket, basically round bracket, curly bracket, square bracket. Determine if the input string is valid. Now they have given some conditions to understand what do you mean by input string is valid or not. So first thing first, an input string is valid if open brackets must be closed by the same type of bracket. Okay. What else? Open brackets must be closed in the correct order. Correct order in the sense when it's a curly, it should be a curly. When it's a round, it should be a round. Whether it's a square, it should be a square. Every closed bracket has a corresponding open bracket of same time. Okay, let's go through some input. Does this clarify the criteria to be a balanced parenthesis? True, so output become true. What about this one? Opening round, opening square, closing square, opening curly, closing curly. Output true. What about this one? This opening is round, but the closing is square. That's why the output false. What about this one? Output true. Length is given as 10 to the power 4, and the string will not be empty as per this said, at least one is there, and S can consist of only these three kind of parentheses, round, square, and curly. Okay, let's take this problem statement first. This is good. Example 1, input, output, input, output, input, output. The function that you have to complete is this one. There you go. And what else? The function that you have to complete on the Java side. That's this one. Public Boolean is valid. All right, guys, that's it. Now, before we go to the solution part or before I give you guys time, let me give you some test cases. You guys tell me whether it's a valid or balanced parenthesis or not. This is the first one. This is the second one. And what else? Let me also make this is the third one. Okay. Tell me for these three test cases I put in the chat. Is first one balanced? Look at the order, look at the number. The output is yes, output is true. Second one, is it balanced? It is not balanced. Let me write it as balanced here. It is not balanced. Interesting part is, does it has equal number of opening and closing bracket? Does it have equal number of opening and closing bracket? It has equal number of opening and closing bracket, despite that it is not balanced. So just merely counting equal number of opening and closing bracket is the right criteria. Come on, guys, click in the chat. No, it is not the right criteria. So what is going to happen here? Even though it has equal number of opening and closing bracket, it is still not a balanced line. Third one, balanced or not balanced? Come on, guys, click in the chat. Balanced or not balanced? This is also not balanced. Does it have equal number of opening and closing brackets? It does. But despite that, it is still not balanced. So one thing is clear. I am looking for two things. First, equal number of opening and closing bracket. That is for sure. But even more than important than that, they should be in correct order. That is even more important. Merely counting the number of opening and closing bracket is not sufficient enough. Everybody clear? Merely counting opening and closing bracket is not sufficient enough. You need to make sure they are in the correct order. Okay. All right, guys, that's all about the problem statement. Now I can give you time. Actually, we don't have time. We have around 2 minutes. We will not be able to solve in 2 minutes for sure. But try this question as homework. And if we can directly start with the solution in tomorrow's session. This is a really good problem statement. Then we have a follow-up question on top of that as well. Okay. So try this problem statement for homework, and then we'll discuss in tomorrow's session. Let me start with a quick revision that we discussed as part of today's session. Good thing is we covered all the theory and we start with the question. Tomorrow we'll be resuming with the question itself. All right, this is work in progress, not a to do anymore. Now continuing with this. We started with a quick last question for our string, which is valid palindrome. We already solved about the palindrome question. This question is just an extension. What we need to do is we just need to make sure if it is not alphanumeric, we skip it. Okay. So we write down the C++ code, O n time O1 space, Java code, O n time O1 space. Then we talked about stacks and queues. We continued with the theory and as well as the question that we started. We talked about what, why, and how of the stack. What is the use case? Most efficient used element will be go of one time, which is topmost element, follows LIF order. We understood the real life example with the packet of bread. Then we moved to the real life application of using undo redo operation, Netflix history, recursion, so on and so forth. Finally, we write down the code as well. We talked about complexity of operation in discussion in detail. All of the operations are big of one. Then we did a one application based question, which is reversing a string or array. Then finally, we talked about queues. We again talked about what, why, and how of queues. Use case of a queue is to get the least recently used element in big of one time, which is the front element in the queue. It follows an order called FIF or FCFS. We talked about the real life example using any queue that you would have imagined. We talked about complexity of insertions. All of them are big of one. Finally, we talked about applications, which include LRU cache, CPU scheduling, as well as input out buffers. Finally, we write down the code and we talked about the complexity in general as well as the code implementation. Last, we have started with our first question, technically second question on stacks and queues, which is lead code 20, valid parenthesis. We have got a good understanding of the problem statement. We have realized it's going to be two things, equal number of opening and closing bracket, as well as the correct order. Feel free to solve it at homework, guys. I don't want to give more time when I start the class tomorrow. It's a good question. Come up with the solution so we can start directly tomorrow with the solutions. Okay. Any doubt in whatever I have told as part of today's session? Anything which is not clear, please let me know. Come on, guys, quick in the chat. If everything is clear, type clear in the chat. All good? All right. If everything is good, let's wrap up the session here for today. Let's catch up tomorrow with the solution of this lead code 20 problem, and then we'll continue with that. Tomorrow we'll be spending all our time in solving stacks and queues interview question. Okay. Thanks for joining in. Have a good one. We'll catch up tomorrow.